Ever wanted to get your hands dirty and code something you can actually hold and play with? Well, today, that's exactly what we're going to do. We're going to use a little bit of code to build our very own digital die, one you can physically shake to get a random number. So let's jump right in and bring this thing to life.
But hang on a second, that brings up a really interesting question, right? Computers are all about logic. They do exactly what you tell them to do step by step. So how in the world can a machine that's so predictable do something as unpredictable as rolling a die? That's the puzzle we're going to solve together today.
All right, first things first. Before we can even think about picking a random number, we need a place to actually store all the possible numbers on a die. 1, 2, 3, 4, 5, and 6.
Now, if you've done a bit of coding, your first thought might be, let's just use a variable. But here's the catch. A normal variable is kind of like a tiny little box that can only hold one single thing at a time. There's no way we're going to cram all 6 of our numbers into that one box, so we're going to need a bigger one.
And that bigger, better box is called an array. An array is basically a special kind of variable, one that's designed to hold a whole collection of items, all under a single name. For storing the 6 sides of our die, it is the absolute perfect tool for the job.
And you know what? Making one is actually super simple. In MicroPython here, all you do is give your array a name, we'll call it score, use an equal sign, and then just list out all your numbers inside a pair of square brackets. That's literally it. It's just a really clean way to keep all your related data together.
The best way to really picture what an array is doing is to think of it like a shelf. The whole shelf is our array, and then each little cubby on that shelf is holding one of our numbers. This little analogy is going to be super helpful in just a minute.
So if our array is a big shelf, how do we tell the computer, hey, go grab the thing in that specific cubby? Well, we use its position number. And in the coding world, we call that an index. Every single item in our array gets its own unique index number so we can find it in a snap.
And this brings us to one of the most important, and sometimes kind of weird, rules in all of programming. Computers always start counting from 0. So the very first item in our array isn't at position 1, it's at index 0. The second item is at index 1, the third at index 2, and so on. It feels a little weird at first, I know, but you get used to it, and it's totally fundamental to how this all works.
Okay, so we've got our shelf full of numbers. We know how to find any one of them using its index. Now for the really fun part, the magic. How do we get the computer to pick one at random? This is really the heart of our whole project, isn't it? We've got our data all nice and organized, but how do we introduce some genuine, real-deal randomness? We need a tool that can just look at our list and pick one without any kind of predictable pattern.
And the tool that does exactly that is called a random value. Most programming languages have this incredible built-in ability to just invent a number that seems totally random. And crucially, we can tell it the range of numbers it's allowed to choose from.
Now in MicroPython, this power isn't just sitting there ready to go. We actually have to ask for it. We do that by importing something called a library. Think of it like this. You need to do a specific job, so you go grab the specific toolbox you need. For our job, we need the random toolbox.
So let's see what that looks like in the code. Inside that random library, there's this awesome command called randint, which stands for random integer. And this is where it all clicks into place. Our die has 6 sides, right? So our array has 6 items, and their indexes are 0, 1, 2, 3, 4, and 5. So we can just tell randint, hey, pick any whole number between 0 and 5. It's a perfect match.
All right, we've got our list of numbers sitting in an array. We've got our tool for picking a random number. It is time to put all of these pieces together and look at the final code.
So our program is going to follow a pretty simple 4-step plan. First, we'll import our toolboxes, then we'll create that array with our numbers. After that, we'll make the program wait for us to shake the device, and finally, it'll pick a random number from our array and pop it up on the screen. Simple as that.
Okay, let's break down the first chunk of code. See those import lines at the top? That's like us gathering our ingredients before we start cooking. We need the microbit library to control the device itself, and of course, the random library for that all-important unpredictability. Right below that, we create our numbers array, loading it up with our values, 1 through 6. Just like that, our setup is done.
Now we get to the main event. This while true part creates what's called an infinite loop. It means the code inside is just going to run over and over and over forever. It's basically on high alert. And that if statement is our trigger.
It's using the microbit's motion sensor, the accelerometer, to constantly ask one question. Have I been shaken yet? Nope. Have I been shaken yet? Nope. It just waits patiently.
And here it is, the grand finale. As soon as a shake is detected, this line of code runs. Now look close. Display.show is going to show something from our numbers array. But which one? Well, instead of putting in a fixed number, we drop our random number generator right inside the square brackets. So, numbers, open bracket, random.randin 0, 5, close bracket, tells the code, first, generate a random number between 0 and 5. Then, use that number as the index to pull a value from our array, and then show it on the screen. It's all connected in one beautiful line.
The code is written. It looks like it should work, but, the whole point was to be random, right? So the only real way to know if we nailed it is to actually test it out.
You know, this is such a critical step in any project. A program can look perfect, but you have to prove it does what you think it does. So let's give our digital die a few shakes and see if we've really created something random.
And looking at these results, yeah, it's totally working. The output is all over the place. It's not going in order. It's not predictable at all. Hey, look, we even got the number 4 a few times, which is exactly what happens when you roll a real die sometimes. This is precisely the kind of random behavior we were aiming for. Success! So let's do a super quick recap of what we just pulled off. We used an array to hold our whole list of numbers. We learned that to grab one of those numbers, you needed to index, and don't forget, that index always starts at 0. We brought in the random library to break away from predictable logic, and we used a physical shake gesture as a really cool trigger for our code.
And that's pretty much it. You now have the fundamental building blocks for creating real unpredictability in your code. So the real question is, what are you going to build with it? A magic 8-ball that gives you random answers? A coin flipper? Maybe a program that picks a random student's name from a list? The possibilities, seriously, are endless.